Difference quotient. Basically what difference quotient is, it's really one of the first things you'll learn when you go into calculus. But basically what it is if you have a general graph, whatever it looks like, you can pick 2 points on that line, and you're basically finding the slope of those 2 points. Now, notice if I keep this one the same, and I pick another point, notice what's happening to my slope. My slope is constantly changing. It could be decreasing or it could be increasing, just kind of depends on what's happening with the graph. But basically what's happening when we're doing the difference quotient is you're really just using the formula for slope. So remember, basic formula for slope, y2 minus y1 over x2 minus x1. But what's going to end up happening is when we have an equation, what we're going to do is the equation looks a little bit different. There's 2 different versions of it. The one, that was the bell. Anyway, but your basic equation is going to look something like this, where you're going to be given an equation, let's say x plus 3, and what we're going to have to end up solving will look something like this. And it has a general formula. General formula looks like this. And what usually happens is we're going to let h represent a possible second point. And then, in a way, this almost looks pretty similar to what your slope formula is. And I guess you could say this might be minus 0, and you kind of put that into place. But basically, all it is just slope formula, and really it's just a massive substitution. So here's how it works. Alright, so basically what we're going to do is we have 2 substitutions. The first part, we're going to plug in x plus h anywhere we see an x. And so we will have x plus h squared minus 4 times x plus h plus 5. Now, we have the minus still, so which means, because we're subtracting, whatever follows next will all be in parentheses. And notice it's really just the original equation, but you're subtracting the whole thing. So that's why I'm putting in the parentheses, because I want to make sure I distribute that negative. And that's really the difference quotient right there. Now it's just a matter of cleaning this up. So on that part I have x squared plus 2xh plus h squared minus 4x minus 4h plus 5. And now I have a minus x squared, I have a plus 4x, and now I have a minus 5 all over h. And of course we have h cannot equal 0, and usually that just tags along. Okay, so now it's just, like I said, really cleaning it all up. We have x squared goes against the x squared, and usually those are going to wipe themselves out. The minus 4x goes with the plus 4x, the minus 5 and the plus 5 take each other out. So notice really all we have left is we have an h squared, so that's done, plus 2xh, and it helps to mark them out when you're done with them, minus 4h all over h, and h cannot equal 0. Factor out an h, because everything on top has an h, so I have an h plus 2x minus 4 all over h. H cannot equal 0, and if you notice, the h's cancel, and so what you're left with is h plus 2x minus 4, and h still cannot equal 0. And there you go.